Okay, yesterday we continued with some of the warrants for the stop and the give way signs. Okay, uh, so and we looked at the special requirements which are pushed forward by ASTO if you are going to put the stop sign. Okay, so this is something extra which you have to check for the stop sign. So we discussed two-way stop sign, all-way stop sign, give-way sign, and then we moved on to signals. Okay, so in signals, the movements are happening in alternate times. Okay, so it can improve the traffic flow as well as provide more safety. Signal can be used for prioritizing certain users or modes. For example, I showed you a video with the priority for the buses. Signal can be operated in pre-timed mode, meaning the timing of the signal is fixed. It does not change according to real-time traffic conditions. And then we have semi-actuated, coordinated, in which the sensors are put on the minor road. Okay, and the concept is that on the major road, the traffic should continue with minimum number of stops. And then we have fully actuated signals, in which you have sensors in all directions, and this is applied on isolated signals. You cannot coordinate them, so it is better that you do it when the signals are at least this much far from each other. If they are less than 0.5 miles, then you should go for a coordinated system. Okay, so this diagram shows you if you have to prepare signal timing plans yourselves, then you should take into account the volumes. Okay, and the volumes can be divided into three categories for the timing plan of the signal. You can have very low volume, which is here. You should identify timings when you have moderate volume. Okay, and then you should identify timings which have high volumes. Okay, and you can see that in one particular day some of the timings can be repeated. So you can see here, late at night, early in the morning. Okay, so timings are repeated, not early in the morning, sorry. Okay, late at night to early in the morning, and then again late at night. Okay, so timings are repeated. Same thing here. Okay, and same thing here. So you have two different peak hours, one in the morning, one in the evening, and the timings are repeated. Okay, so this may happen near shopping malls or something, but the concept is that you should have at least three different plans. Okay, one for low volume condition, one for very high volume condition, one for something which is intermediate. Okay, if you don't take this variation into your consideration when you are designing the signal timing, then it will fail in a particular time. Okay, the timing which you are designing, if you just consider very low and very high, then you can see in all these hours it is useless. Okay, if you just design for this one, then in all this section and in all this section it is useless. Okay, so you have to consider all these three issues or all these three ranges. Okay, normally the movements which we need to consider for a signal design are 8 normally, depending upon the number of sides you have, obviously. Okay, so if you have 4 sides, then you are going to have 8 movements. Okay, or 8 movements which we consider, which we should consider, which we always consider. Okay, and these 8 movements include through and left from every direction. Okay, through and left. Through meaning what? Straight. Okay, and obviously then we have the, now which 2 movements are not there but can happen at the intersection? Right and U-turn. Okay, right, it can be allowed. Okay, so you can have a right turning which drivers take whenever they have the chance, so they don't have to stop for the signal. So I will only calculate the time for those movements in which the driver has to follow the signal. So in many cases when you are taking the right turn, you don't have to follow the signal. If you have the chance, you can do it. Okay, in many cases. And same thing for the U-turn as well. Okay, you will have very special cases in which U-turn requires a signal, a separate signal timing, where you have to consider it especially. Okay, normally U-turns are not so high. Okay, so these eight movements are more critical. Okay, and they can be arranged in 6 different combinations. Okay, we will talk about it later on. Pedestrians are allowed in one of the phases which you are designing for the vehicles. We are talking about intersections. Remember, all this discussion is about intersection. So there is no pedestrian signal. It's not a pedestrian signal. It is a signal which is designed for the vehicles. Okay. So pedestrians will use the most suitable phase from the phases which are already there. Okay. So we are not designing any separate phase for the pedestrian. It's not a pedestrian signal, and you cannot have a pedestrian signal at the intersections. Okay. In most of the cases, although I have seen it. Okay. There are some signals. Okay. Not here, but there are some signals which are on intersections, and they are especially for pedestrians. Okay, like they can walk like a king from the intersection. Okay, but it's a push signal. So I have seen it for two one-way streets. Okay, so one-way streets, and there's only one signal for the pedestrians, no signal for the vehicles. You can cross, okay, whenever you have the chance. But the signal is there, the pedestrians come, they push the signal, and everybody is stopped. That's why I said you cross like a king. Okay? Because everybody stops for you. Okay? But I haven't seen it here. Okay? In some European countries it's there.
Yeah, I'm sure I think there is.
Yeah?
There is one in Sitra, I think.
Where?
In Sitra.
In Sitra. Very good. Everybody knows where is it. Okay.
Everybody knows Sitra.
It can be near a school or something, maybe. Anyways. Okay, send me the location. Bicycles are treated with the vehicles. Okay, if they are moving on the road. Okay, if the bicycles have to move on the road itself. Okay, they are they are not allowed on the sidewalks. Then they will move with the vehicles. Okay, if you have, for example, if you have bicycle lanes. Okay, here in Ladakh we have bicycle lanes. Okay, there are some other areas where we have bicycle lanes. So bicycle lane is on the road, right? If you have bicycle lanes, then bicycles are treated with the vehicles. If you don't have bicycle lanes, the bicycles are supposed to be on the sidewalk with the pedestrians. They will move with the pedestrians. Okay. Yeah. You can have 12 movements which are assigned to the phases. Okay, each green phase, each green time can have some of these 12 movements, right through and left. Okay, each phase has a fixed timing. If it is a pre-timed signal, then each phase has a fixed timing. If it is a actuated signal, what do we mean by actuated? It's connected with the sensor. Okay, so the sensor will change the timing. So there is no fixed timing, but as a programmer we have to go for the minimum and maximum. You have to fix the minimum maximum in the programming of the signal. Okay, the sensor, whatever timing it's changing, it's in this range. Okay, it will not go below minimum, it will not go above maximum. Okay, yeah. So one phase means the timing which is assigned for one movement. Okay, the signal timing assigned for one movement is called as what? A phase. Okay, and if you add the timing of all phases, we call it a cycle. Okay, and the time which is taken by one cycle is called cycle length. Okay, it's called length, but it is time. Okay, got it? Okay, this is just giving you some of the combinations, possible combinations. Okay, so you can have something like this. So you can see in this direction, in the east-west, right? East-west direction, the movements of the same direction are happening together. Okay, these two together, these two together. Okay, but in the but this one has more time now. The left turning has more time. Okay, so what happens? The two left turnings are open. Okay, and then you go to this phase. So in this phase, what is happening? This left turning continues, but now the straight has started. Okay, then you from here you go to this one. So this straight continues, and this straight also started. So the left turning is closed now. Okay, so you can go in this way, or you can go in this way, which is the mirror image. Okay, so now this thing is happening in the other direction. So the two left turnings. Okay, then you go from here to straight and left, then two left, then straight and left. Okay, for the other direction now. This one was for east-west direction. This one is for the north-south direction. Okay, and you can interchange as well. So you see here, this is one combination. Finish east-west, then go north-south. So all east-west finished, then all north-south finished. Or what you can do is, you can go like this. Okay, so east-west finished, and then you go to north-south. Okay, then you start with two movements around north-south, and then you go again to the east-west. Okay, so different combinations. There are countless combinations. If you observe when you are going home or coming from home, okay, if you have to stop at a signal, you can see at each signal you may see a different combination. Okay, sometimes the straight and left is happening together, sometimes the left and left is happening together. Okay, so there are many combinations. These are just some examples. Okay, some terminologies which we use in signal design. Okay, for example, we have a terminology which is called interval. Interval is the timing of the signal, is part of a phase. Okay, and it is that part of the phase when the signal light does not change, the signal indication doesn't change. Light green, so green is an interval. The signal is green, we have the green interval. From green it will go to yellow, so it will be the yellow interval. Clear? Okay, so interval is that part of the phase where signal timing doesn't change. Then we have the phase split. Okay, yeah, so phase split is the time which is part of a cycle in which one or more movements are going together from the intersection. So they are allowed at the same time to go to from the intersection. For example, this one. So this is a phase, right? Okay, but in this one phase, how many movements are happening? Two. Okay, but since they are happening together, we call it the same phase. Okay. So the phase is the amount of time given for one or a combination of movements to happen together. Okay. So in one phase, we have three intervals. In one phase, we have three intervals. We have green, we have yellow, and we have all red. Okay. All red means all directions have what? Red. Okay. So why we are saying it is part of the phase? Well, everybody has red. Red phase was what? How did we define phase?
Timing for a
Movement, right? The movements are having red. So why do we put it as part of the phase? All movements have red.
The intersection there counts.
Yes.
Clear.
Okay. Yeah. So this is for clearance. So even in all red, cars which are in the intersection can move. But these are the cars which are from the previous phase. The phase which was having yellow. Okay. Yellow, green, red. See, we should stand in a line and go together, right? Okay. So all red is for the movement which just finished yellow. Okay, because those cars are in the intersection and they are allowed to move. Okay, so that's why it's part of the phase. The cycle I told you where you add all the phases and that will give you the cycle. Yeah, only those phases are added which are not overlapping. Okay, so overlapping, is it here? It's not here. Okay, if you look at this one, okay, so these two movements are happening together, okay, but they are in different directions. Okay, this is happening from the eastbound direction, this is happening from the westbound direction. Okay, so they are actually in different sides, so there are actually two different phases, but since they are overlapping, you will not count them twice. When you are calculating the cycle, you will not say phase 1, phase 2, phase 3, phase 4, no. The overlapping phases are counted once. So phase 1, all together, phase 1. This all together, phase 2, phase 3, phase 4. Got it? Okay. So if movements are happening on in different directions at the same time, this is overlapping. So overlapping will not count it separately, just count it once. Okay. Okay, what is a lane group? One or more lanes on an approach that operate in the same phase. Okay, so in one, so you see here, there are 3 lanes. In this approach, there are 3 lanes. The lanes which will operate together from this approach, they will be considered in one lane group. Okay, so for example, you have a phase for straight. Okay, so for the phase which has straight movement, how many lanes will be moving together? The top 2, right? This one is not part of this phase. So these 2 are in one lane group. Okay, these 2 are in one lane group. And the third one, because it will not operate with them, this is in another lane group. Got it? Okay. So how many lane groups we have? 2. This one with 2 lanes and this one with 1. Okay. So our lane group can have a single lane as well because no other lane is operating with it. Got it? Okay. So those lanes which are on the same approach and they operate together in a phase. So they are considered part of a lane group. Okay. And if you have only one lane which is operating in a phase, so the number of lanes in that lane group will be 1. Okay. So lane group can have a single lane and it can have more than one. Clear? Okay. Okay. Saturation flow. You remember capacity, right? What is capacity? Maximum flow, maximum volume. There's only one thing left now. She is very smart.
Amount of vehicles
She doesn't know the answer. Well, what she's saying is right.
Amount of vehicles can carried by signal.
Maximum what? Maximum. He's saying flow.
Maximum.
He's saying volume.
Maximum vehicles.
Maximum.
It can carried by.
But what do we call it? There's exam tomorrow, right?
So.
Yeah, I will wake up in Tahajjud, I will pray. Inshallah. There will be exam. Okay, maximum what? There are 3 things. Flow, volume. Very good. Huh?
Maximum height maybe, maximum down, maximum anything.
Maximum grade.
Good, yeah.
F. Okay, we will see tomorrow, inshallah. Okay.
How many questions by the way?
2.
2 questions, 1 each?
Yeah, 1 for you, 1 for him.
No.
What 1 each?
One from lecture 1 and from lecture 2.
I don't know.
Job lectures there, it's not.
See, he doesn't know. Okay. Okay. Saturation flow. Okay. Saturation flow is like capacity for a signal. Okay, saturation flow is like capacity for a signal, but this is an ideal value. Okay, saturation flow is an ideal value for a signalized approach. Okay, ideal value of capacity for a signalized approach. The maximum number of vehicles that can pass from a signalized approach in 1 hour without any stoppage. That's why I'm saying that is ideal. Because if you have a signal will become red as well. When it becomes red, there will be stoppage. Okay, saturation flow rate does not take into account the red time or any other time when the vehicle is stopped. Okay, so that's why we call it, this is the ideal. Okay, it is always per unit of time, and the time is 1 hour. It is per lane as well. Okay, so saturation flow is always per lane per hour. Okay, what else? Lane group capacity. So capacity of the entire lane group. Okay, under signal timings. Okay, so what's the difference between saturation flow and lane group capacity?
This is for the segment and this is only.
No.
Oh, sorry.
What's the difference here?
Ideal.
No, these are the per hour. But what's the difference? I said this is ideal.
Yes.
Why?
No stop.
Non-stopping. Okay, this is with the timing. So timing means there will be stoppage. There will be a part of the hour where the movement is not happening, right? Okay, so this is not considered in this one, but this is considered here. That's why these are two different things. Okay, volume to capacity ratio, we have used it earlier as well. You have volume, you have capacity, you take the ratio, and so on. Clear? Lost time, like now, wasted time. When no vehicles are moving through the intersection. Moving through the intersection meaning when they are not entering the intersection. Moving through means when they are not entering the intersection. So lost time for one phase is represented with a small l. For the whole cycle, it is represented with capital L. Okay. So you have the lost time of each phase, which could be different, it could be same. But when you have it for each phase, you add the lost time of all the phases together, you will get capital L. Okay. Effective green, the time of the phase which is usable for the movement, which is usable for the movement. So the phase time includes 3 intervals. Which ones?
Green, red, or red, yellow.
Green, all red, and yellow. Okay. In some part of this time, the vehicles are not actually entering the intersection, like they are not crossing the stop line. Okay. If you subtract that time, the remaining is called effective green. So you take the total time of the phase, subtract the time when you are not allowing the vehicles to enter, or subtract the time when the vehicles are not entering, either you are not allowing them or because of some other reason, and then you get effective green time. Okay. Critical lane group. Yeah. Let's say I have a phase in which all these 3 lanes are going together. Okay. Now you see these 2, I told you, right? They are part of the one lane group, right? Because they have the same movement. Okay. And this is part of another lane group. Okay. So I am giving this phase and this phase at the same time. I am giving the phase for this lane group and the left turning lane group at the same time. Okay, so they are overlapping. But when I will design, their volumes will not be same, right?
So
The volume of this one and this will not be same. Okay, but you have to design for one of them. Okay, the one which you will design for is called critical lane group. Okay, the one which you are designing for the timing is called the critical lane group. If you have more than one lane group which are moving at the same time, you can see another example here. There is mentioned here. Now you see this one lane group, and this one another lane group, right? They are happening together. So they are overlapping. But I need one timing. Okay. Which one will I take from them? the critical one. The high, we'll talk about it. Okay. So we don't take the critical lane group based upon higher volume. We take it based upon higher V upon S ratio. What is V? The volume. What is S? The saturation fluid. So whichever lane group has a higher V by S ratio, volume to saturation flow rate ratio, that will become critical. Okay. So you may have a lane group which has higher volume, but it is higher saturation fluid as well. So the ratio could be less. Okay. If you have multiple lane groups which are happening in the same phase, you will calculate V by S ratio for each one of them, and for the design you will take the one which has the highest ratio, and that one is called as critical lane group. Okay. Overlapping, I already explained, different movements which are happening in the same phase. Permissive movement. Okay, a movement allowed only after opposing movements of pedestrians have cleared. Okay, and it is indicated by a green ball signal. Okay, so signal becomes green, and that means that any opposing movement is now cleared. Okay, and then we have protected movement, the movement which has the right of way. I think there is anyways, I'll give the concept, don't worry about these words. Permissive movement is that movement. Okay, so basically this part is extra here, this should not be here. Okay, permissive movement, this is the definition. Okay, you can cross out this one, this thing. It's not again indicated by any signal. So a permissive movement is allowed when the opposing traffic and pedestrian volume is cleared. Okay, so you don't look at the signal. If it is cleared, you go. Okay, so in this case, you don't have the right of way. You can only move it if it is clear. If it is not clear, you have to stop. Okay, so right of way does not belong to you. Okay, that movement is permissive. And protective movement is the one which has a proper green time from the signal. So when the signal becomes green, this movement has a right of way. Okay, anybody else who is in the intersection at that time doesn't have the right of way. Okay, so you can just go and crash with them, and obviously. Okay. Then we have protected permissive movements. This is when you make movement permissive for some time of the day, and the same movement is protected in some other time of the day. Okay, so for example, right turning, let's say. So you have maybe 2 or 3 hours of the day where the right turning becomes protected. For the rest of the time of the day, it is permissive. Okay, and it is done when the movement has less volume, or like less volume in most times of the day. Okay, so the movement is very low, so I don't feel the need to design a signal or a phase for that movement. But there are 1 or 2 hours of the day when that movement has very high volume. So if you allow it to become permissive at that time, it will include either a very long queue or too many crashes, because people will try to enter because they have a queue behind them. Okay, so in those hours where you feel the timing is, the volume is very high, you can make that movement as protected. So you give them a separate green phase. Okay, to avoid any confusion and so on. Okay, and to give them enough time. But the problem is the drivers. Okay, they have to be knowing in advance when it is protected, when it is permissive. Okay, so that's an issue with this. Then we have 2 types of sequences for the phases. Okay, the phases of the signals can have a leading sequence or a lagging sequence. Okay, leading means the turning happens first and then the through movement. Okay, leading sequence means I have turning movement and I have through movement on the same approach. This one, that's it. So I have a phase for this movement and I have a phase for this movement. If this one happens first, this one has green first, and then this one, this is called leading sequence. Okay, and if this one happens first and then the turning, then this is called as lagging sequence. Lagging, right? Okay, so leading and lagging is with respect to the turning movement. If turning movement receives green first, it becomes leading sequence. Okay, if turning movement receives green after the straight, it becomes lagging sequence. Okay, if they are together, then okay, no problem, there is no leading and lagging. If both movements are happening together, turning and straight, there is no leading and lagging.
Most segments be lagging, right?
Sorry?
Most segments become lagging, right?
Maybe. It depends upon where the cycle has started. Okay, get the idea? Okay, now we move on to critical movement analysis. Critical movement analysis is a quick and easy method for estimating the capacity of the intersection. The whole intersection, not one lane or one phase or one approach. Okay, so it gives you an approximate value. It's not very accurate. Okay, the basic principles are behind the analysis. The main principle is two conflicting movements cannot be at the same time at the same point of the intersection. So if there are two movements which have to cross each other, okay, so it will happen one by one, right? Okay, first this one should go and then this one should go, right? Okay, so the total time available is what? 1 hour, right? Capacity is vehicles per hour, so total time is 1 hour. Now in this 1 hour, it will be divided into conflicting movements. This one is 600, this one is 600, so half of the time for them, half of the time for the other movement. Got it? Okay, so the capacity is calculated by the amount of time which is available for each movement. How much time is available for each movement? Okay, saturation flow rate is the input which we require to calculate the capacity. Saturation flow rate is 3600. What is this? Seconds in 1 hour, right? Divided by H. What is H? Saturation headway. H is saturation headway. Now what was saturation flow rate?
Maximum volume in ideal condition.
Maximum, right? So this is maximum. So H should be minimum, right? Minimum H will give you maximum flow rate, right? Inverse, right? So H, when I say saturation headway, that means this is a minimum headway. Okay, and again saturation flow rate was for signals, so headway is also for signals. Okay, but the minimum value. Critical movement analysis adjusts the value for the lost time typically by 20%. Okay, so whatever value is calculated, okay, it is adjusted by 20%. So if the full capacity was, let's say, 2000, okay, then adjustment for the lost time, so it will reduce by 20%. Got it? What was lost time? What is lost time? Yeah, I know the feeling, but it's defined as what?
There is no
All red
section.
and yellow.
All red and yellow.
No car in the intersection.
No car in the intersection.
No car allowed to enter.
No car allowed to enter the intersection. Okay, no car is allowed or not entering the intersection. Okay, the time in which no car is entering the intersection, whether it's allowed or not, something else, but no car is entering the intersection. So in this analysis, because it's a rough estimate, so they are saying, okay, let us consider that time to be 20% when no car is entering the intersection. Okay, where can we use this critical movement analysis? We can use it at the planning level. So planning level is done for something which will happen years in the future, after 20 years, 30 years. So for 20, 30 years, you cannot get the exact data. So this can help you. You are trying to see a different number of lanes. What if I give 2 lanes for left turning? What will happen if I give 3 lanes for straight? Okay, so there can be many options, right? For each option, if you do the detailed analysis, will take a lot of time. Okay, so you can do this quick analysis and see for each lane what is happening. Yeah, you are trying different phases of the signal, different phases and their combinations. Okay, again, if you try one combination and then do the whole analysis, and then try another combination and then do the whole analysis, it will take a lot of time. So this method is quick and easy way of comparing between different phases. So you try one combination, use this analysis, it will take less time. Okay, so it will be easier and more efficient to compare. Yeah, you are using any software, the software tells you that 10 types of combinations were used, and from them this is the best one. Okay, so we don't trust anybody, even the software. Who made the software? No. Huh? No, somebody else, right? If I made it, you cannot compare, obviously. Okay, it will be perfect. That's why I don't do it. So to check the calculations from the software, decision from the software. Okay. Again, last point is the same as the previous 2 points. Okay, you are comparing between different alternatives and you want to see what will happen in each case. There are 6 steps for this type of analysis. First of all, identify movements, and for each movement, find out how much volume you are expecting per lane. Okay, per hour per lane. Then, second step is assign movements to phasing sequence. Okay, so you should have a phasing sequence and you decide how many movements will happen in the same phase. Then find out critical volume pair for each interval. Okay, the pair which will give you the highest summation. Volume pair means what? Two volumes which are conflicting with each other. Two volumes which are conflicting with each other. Okay, so this one and this one, they are conflicting, right? So this is a pair. Okay, and then they can be the one which is happening in the other direction. So this is another pair. Okay, so see different pairs, and the pair which has the highest sum of volume. Each time you have two, right? So this plus this, and then this plus this. So which one gives the highest sum for both movements? So you will take that as a critical one. Okay, sum the critical volumes, sum the critical pairs from different phases. Okay, so you have now total critical volume, and you can compare it with the saturation flow rate. Okay, now saturation flow rate, I told you it was 3600 upon H, right? Okay, so you must have the value of H. For our convenience, they have given us some standard values. Okay, for example, you can take saturation flow rate to be 1400. Okay, but it is considered as a safe estimate, a conservative estimate, something on the lower side. In highway capacity manual, they have gone up to 1530 as well. Okay, but you can find out your own saturation flow rate if you know the minimum headway. Okay, so you can find out this one as well. So calculate volume to capacity ratio. So this is the volume, this is the capacity. Calculate the volume to capacity ratio. Okay, and then you can find out the status of the intersection. If the total volume to capacity ratio is less than 0.85, we call it under capacity, and you can expect low to medium delay. Okay, and minimum queuing. Okay, total volume to capacity ratio. If volume to capacity ratio is in this range, then this is very near to capacity. The delay will be high. Okay, but the queue will still be on the lower side. Then 0.95 to 1 is exactly capacity. The delay is very high, and you can expect that sometimes the queue will not be clear, and the signal will become green because now you are very close to the capacity, right? Okay, capacity is when the entire queue is gone. So maybe some of the drivers are slow. Okay, they are looking at the phone or something, so they will not be going. Okay, so there can be some signal phases in which the whole queue cannot pass. Okay, and more than capacity we already know. Okay, then the delay is very high and the queue is also very long. The queue will keep on getting longer. In this case, the queue will keep on getting longer. Every phase, the queue will increase. Okay. Okay, this is an example. Okay, the example is for this intersection, the same which I showed you earlier. Okay, so the first two steps were, you have to, step number 1 was identify movements and the volume for every movement. That already been done. Okay, which movements are there and how much volume you can expect for each movement, that has been done. Assign movement to the phasing sequence, that has already been done as well. They already made the phasing plan as well. Okay, so we are starting with step number 3 here. Okay, obviously we did not discuss the phasing plan yet. Okay, so we are starting with phase number 3. What was step number 3? Step number 3 was determine critical volume for each street, for each highway. Okay, so considering the east-west direction first. Okay, so if you are taking left turn from here, then you will be crossing with this movement, right? Okay, so eastbound left turning will be crossing with westbound through and right, because these movements are happening together. See, they cannot happen differently because they are happening from the same lane. Okay, so this one and these two, this is one pair of movement. Okay, and the second pair can be what? This and this. Okay, so now for this one, okay, so left turning from eastbound, it's given here, the volumes are given here. Eastbound left turning 130. This is westbound through and right. Okay, so westbound, this one, through is 400 and right is 96. Okay, now if so this one will be given half of the time. Okay, for the crossing movement you have to give half of the time to one of the movements. Okay, so this one will be as it is and the other movement will have half of the time, so that's why 0.5. Got it? There are two pairs, right? They are conflicting with each other. Okay, so one of the movement in that pair should have half of the time. Okay, so 130, this one, eastbound left, the other one will be taken for half of the time. Okay, so this is one pair now, one conflicting pair for east-west. The total is 378. Okay, for the other one, so this left turning and this is straight. Westbound left turning and eastbound straight and right. Okay, so again same thing.
In the same time or?
No. Different. Okay, so we will do the same thing. This is westbound left turning. Westbound left turn. And then eastbound through and right. Eastbound through right. Okay, and again this one will be given half of the time. Okay, and you add them together, you got 630. Okay, now for this street, there is 378 with this combination and 630 with this combination. Which one is more critical? Okay, the same thing will be done for these movements as well. Okay, again this one left and this one through and right, and then this one left and this one through and right. Okay, and each. Sorry?
Always through and right and left.
And left. Okay. So now you can see here again we have 312 and 450. Which one is more critical? 450. Okay, whichever one is higher. Whichever one is higher. Okay. So now we will add the critical. We have critical from the east-west direction and we have critical from the north-south direction. You will add them together. This will give you total volume. Okay, this will give you total volume. Okay, after that, we'll assume the maximum critical volume, the saturation flow rate. Okay, I told you they have given us some recommended values, right? Okay, so we are picking one of the recommended values which is on the lower side. Okay, so let's say the total saturation flow rate can be 1400. Okay, so your total volume, total critical volume is 1880 and your saturation flow rate is 1400. Okay, so what is the V by C ratio here? How much is it? Okay, if I go to this table, then I have under capacity conditions, the Q is minimum and the delay is low. Clear? Okay? Good. Okay, this is another example. Okay. Again, the same things are given. Yeah. So this figure shows you the arrangement of the lanes, and this figure shows you the volumes. Okay, for each direction. Okay, 110 for right, 360 for straight, 170 for left, and so on. Okay, for each side. How many lanes we have here? 3. One for left turning, one for straight, and right. Okay, same things here as well. How many lanes here? 2. One for left, one for straight and right. Clear? You will apply the same procedure. Okay, one for east-west, one for north-south. Find out the critical one for east-west, find out the critical one for north-south. You add them together and then divide by the saturation flow rate, the recommended value. Okay, clear? And you can see what type of intersection, what type of condition you have. Any questions?
So we will do this example next.
No, you will do it.
No, we need, I think, we need to repeat also the previous example.
Okay, I will repeat. Let's repeat.
Next lecture, inshallah.
Huh?
Next lecture.
Next lecture I have to start from the beginning. Tomorrow's exam. Yeah, I know.
So we always choose 1400.
What?
We always take
No. This is one of the values. Okay, you can choose 1400 or you can choose 1530 or you can find out your own minimum headway and find out the saturation flow rate. Okay, so this is not fixed. Saturation flow rate is not fixed. Okay, what is your question? Tell me.
Next lecture.
No, tell me. Next lecture I will not open this. Believe me.
It's confused actually at the beginning.
Always looking forward, not going back.
Obviously.
Multiply by
We only go back in the exam.
0.5 because they are in one group.
Yes.
So can we go to the next slide? So here, north and south, we don't have to divide by 2, right? No, on the left side. This one, left one. Because they are separated groups, so we don't have to multiply by 0.5. Separated. This is one group and this one.
No. No, this one will conflict with this one. So this and this, we are adding this and this. Conflicting movements. Yeah, we are adding conflicting movements.
No?
So
This was the basic
we
principle,
deal
right?
with conflicted point only.
Okay. This is the basic principle here. Two conflicting vehicles cannot be at the same point at the same time. Okay, so this is for division of the time. Okay.
Say that. So.
Hmm?
Say that only.
Yeah, that's why I'm saying ask the questions.
The question 15
Hmm?
the numerical question 15
See his question. His question is about questions. Two question what?
Two questions 50 minutes.
15 minutes? 1 5?
50.
Huh? 40 minutes. 40, yes.
مثلا
Huh?
12 to 12
12:40 is what?
You're
You will come to the class, he will come late, he will come late, and you will come late. You will come late, you have to get your coffee from somewhere. A special coffee, half meter. Okay, so you